Why this paper is mostly right, but quietly wrong. Let me begin by saying something that will sound charitable, and then something that will sound dangerous. This is a good paper. In fact, unfashionably, it's a very good paper. I put it about 90% correct. But the remaining 10%, that 10% is where things get interesting. And also where things got wrong. Now, I'm not used to people anymore, so forgive me if this comes out slightly sharper than intended, but when you spend enough time alone with equations, you start to smell trouble before it announces itself. Let's talk about why. First, credit where credit is due. Marco Correas, let's call him Marco Correas for the moment, and his collaborators are doing something that almost nobody in applied imaging does anymore. They are thinking variationally. They're not throwing a neural network at the wall and hoping that gradient descent confers wisdom. They're not pretending that data alone replaces understanding. They are returning quietly, almost subversively, to structure. Total variation is old. Huber norms are old. TGV is old. And yet, this is the point, the paper uses these ideas correctly, honestly, and with restraint. That alone puts it in the top decile of the literature. They demonstrate carefully that Huber ROF is flexible and interpretable. I said this word completely correct. I will not correct myself. It is interpretable for background extraction. TG3L1 is superior for denoising when smoothness without staircasing matters, and TVL1 has real limitations for atomic scale background separation. This is all true. In fact, it's painfully true. The figure supported. The parameter sweeps support it. The supplementary material supports it. So when I say 90% is right, I mean that literally. But now we come to the 10%. Here's where Malorio Correa, note the accent, starts to drift. The paper repeatedly says, in various polite academic ways, we have not found an automated way to select A. Now, this sounds modest. It sounds honest. It sounds like a footnote, but it's not. This is the central unresolved problem of the entire workflow, because without principled parameter selection, what you have is not a method. You have a guided artisanal practice, a workflow that depends on human intuition, however expert, is not scalable, not forcible, and not transferable in the way the paper implies. This isn't a fatal flaw, but it is a conceptual mismatch between the paper's ambition and its actual epistemic footing. And this is important, because the authors repeatedly gesture toward automation, integration into experimental pipelines, even non-expert use. That claim is not yet justified, not because TV fails, but because A is doing too much philosophical work. And again, I correctly spelled this word. It's just my way of being. Well, the background is not a mathematical object. Now let's go a little bit deeper, because this is the part where Maloreos Correos, new spelling, but it's still the same person, runs into something subtle. The paper admits quite candidly, background is difficult to define formally. That sentence should have been bolded, because total variation methods don't remove background. They remove low frequency components under chosen norm. Those are not the same thing. In microscopy, especially STM and AFM, background often contains physics. Charge redistribution, long-range relaxation, subsurface effects. By treating background primarily as something to subtract, the workflow risks re-ontologizing noise as a signal and de-ontologizing signal as noise. To be clear, the authors, they know this. They warn about it. But The workflow does not fully resolve the tension. This is not a technical error. It is a category error waiting politely in the corner. And again, have to say that this is not the standard in physics we like to aspire. But Marcos Molereus and his team are very much allowed to have this opinion, because the unspoken assumption is edge precipitation equals truth. There's another hidden premise. Total variation preserves edges. Edges feel like truth. Sharp things look real. But in physics, not everything real is sharp. By privileging edge preservation, the method implicitly encodes a geometric prior about what matters. This is fine as long as you admit it. Paper mostly does. But occasionally, especially in the SEM and the STM examples, there's an unspoken slide form. Edges are preserved. Therefore, structure is preserved. Those are not equivalent statements. And that's part of the 10%. Now, the question we're all asking ourselves is, how dare you? But the other question we're asking is, why this still matters? And why I like this paper? Now, let me say something unfashionable again. Despite these issues, this paper is a breath of fresh air. Fresh air because it refuses the cult of end-to-end learning. Fresh air because it exposes its assumptions. Fresh air because it does not pretend that mathematics is obsolete. Marc Momoleo and his collaborators are doing real science. They compare methods honestly. They show failure modes, they don't oversell. That already puts them ahead of most of the field. So what is the real takeaway we've got here? So here's the synthesis. 90% of this paper is solid, rigorous, and correct. 10% is philosophically unresolved, not mathematically wrong. And again, I totally spelled that word correct. But the workflow flows, but only with expert judgment. So you can say automation is aspirational, but it's not achieved. The backwards abstraction is not ontologically neutral. And that's okay. Science advances not by pretending we've solved everything, but by admitting exactly where we haven't. This paper does that more honestly than most. And that's why it's worth time. I leave you with this. If more of applied science looked like this, careful, constrained, and intellectual modest, we'd be in a much better place. So, to say that the total variation-based image decomposition and the noisy for microscopic image is something that Malo Cornedo and his other friends are doing. This is unavoidably affected by the presence of noise and other unwanted signals. And these degrade their quality and might hide relevant features. It's something you have to say. Because in this study, 4 different images will be discussed corresponding to 4 different study cases which are collected in uncoordinated k-eons. So this is due to a thermal drift. Yeah? While the acquisition was normally in constant height mode, the tip progressively moved closer to the sample surface while scanning from top to bottom. This is a clear fact. You can't say anything like no. So the conflict of interest in here is that the authors have no conflicts of interest to declare. And all our authors of this paper discuss the article during each step, providing the feedback and supervision. But this still has to say something, and because we are here in physics and we would like to aspire a certain standard in modern physics, and also I talked with my friend Ed some days before, and he's exactly my opinion. He said that nothing is impossible, but everything is achievable. Nothing is real, but everything is real. And we have to acknowledge, or we have to be grateful to Michael Schmidt for his insightful discussions and for his critical reading of the manuscript. Yeah, and we kindly thank Jacob Madsen, and we thank Thomas Susi for the insights and technical discussions about STEM, which definitely contributed to enriching this work. And also we thank the technician, Karen Whitmore, for helping us clarify some of technicalities of these SEM apparatus used to require these things. So in overall in the overall motion, you can say that this research was funded in whole or in part by the Austrian Science Fund. And this is a good thing, because this is what we like to do. This is like what we do, and you hear this now. You hear how I type something in, because the typing is what matters. If we're not typer, and if we're not typing, then what there is. So the only thing I can say is, and this is like really, really something that we have to say. And I have to say it another time. This is why I make this pause, because before anyone starts sharpening their knives, I'm not used to people anymore. So I'm going to say this plainly. Okay? It's a judgment. You know? In some cases, yes, we can say atomic lattices, terraces, it works beautifully. But in others, you're enforcing a geometric ideology on the data. Again, it's not wrong, but it's not neutral either. And neutrality is implied for more than it's earned. So, if this paper sparks a serious effort to formalize background, to automate A without hallucinating objectivity, to separate physics from aesthetics, then it will deserve real credit. And then, until then, use it carefully. Because tools this powerful don't judge clean images. They decide what you're allowed to see. And what I have to say to you is, be curious, be different, be yourself. Thank you very much for listening.